All right. So with x and y intercepts, the question is, how do we determine intercepts? Okay. Now, in terms of definition, the point at which the graph intersects the x-axis is called the x-intercept. Likewise, the point at which the graph intersects the y-axis is called the y-intercept. So you can see in the graph right here, Riley, that where the graph crosses the y-axis, we've got a point. That point is representing the y-intercept. Now, this particular point has the coordinates 1, 2, 3, 4, 0, 4. Okay? Now, notice that the x value is 0 for this y-intercept. Alright? Likewise, the x-intercept is where the graph crosses the x-axis. Notice the coordinates for the x-intercept. Notice that 0 is the y-coordinate for the x-intercept. This is extremely important. This is extremely important because when we start finding x and y intercepts, to find an x, we're going to plug in 0 for y. To find y, we're going to plug in 0 for x. Alright, now the x-intercept is also referred to as a 0, and technically it's 0 of a function, root or solution to the equation. There are multiple ways to represent x-intercepts or to describe x-intercepts. Zeros of a function, roots of a solution, or just solutions in themselves. Alright, now when we find these intercepts algebraically, all we're doing is plugging in 0 for one to solve for the other, and vice versa. To find the x-intercept of an equation, set y equal to 0 and solve for x. So underline this part right here, set y equal to 0. If you have a highlighter, you can highlight it. To find the y-intercept of an equation, set x equal to 0 and solve for y. You can use these points to graph the equation. So in this first example here, let's find the x and y-intercepts of this equation. So it's just a slope-intercept form. So to find it doesn't matter which one you find first. Let's find the y-intercept first. Okay, to find the y-intercept, we're going to plug in 0 for x. It's that simple. Y equals negative 2 times 0 plus 5. Now what does that simplify to?
Pretty much
just 5. Okay? Because anything times 0 is 0. Alright, then we find the x-intercept. The x-intercept means I plug in 0 for y. So 0 equals negative 2x plus 5. Now to solve for x this time, I've got to subtract 5 from each side. That gives me negative 5 equal to negative 2x, and then divide both sides by negative 2. So x equals 5 over 2. So my y-intercept is 5. My x-intercept is 5 over 2, which is 2.5. Now, this is not written in the form of coordinates. If I wrote this in the form of coordinates, it would be 0x 5y. If I wrote this one in the form of coordinates, it would be 5 over 2x, comma 0y. Now, I'm not asking you necessarily to write it as coordinates. If you know what the y-intercept is, then you can just go there. You just go there and graph it. Just make sure you put the y on the y and the x on the x. Alright, look at the examples. Find the x and y intercept of each equation, then graph the equation using the intercepts. So this is in slope-intercept form. Now, to make things a little easier on ourselves, if we put it in standard form at first, it might save a little bit of work later on. So that's what the video showed. So let's take this 5x and move it to the other side. Now you don't have to get it in the formal standard form. What I mean by that is you don't have to have the a value greater than 1, greater than or equal to 1. You don't have to have integer values for a, b, and c. You can just get the x and the y on the same side, and that's going to be probably good enough. So we're going to subtract 5x from each side. So y minus 5x equals -1. Now again, I don't have to put the x first. It doesn't matter. I just want them on the same side. That's going to make slope-intercept form easier. I mean, it's going to make x-y intercepts easier. So let's find the y and then the x. Does it matter which one I find first? No. So to find the y-intercept, what am I going to do with this x value?
Just
plug in 0. Now what happens when I plug in 0?
That turns into 0.
It goes away. So what is it?
Y equals -1.
That was easy.
Yes, it is.
The finger trick. It's the finger rule. Alright, what happens when I plug in 0 for y? Goes away, right?
Equals negative
5x equals -1.
x equals -1.
Divide both sides by 5. X equals -1/5. So then I can graph them. So the y-axis has a -1. That's our y-intercept.
Question. Would
Yes.
it be positive if it has a negative x?
Yes.
Be a negative x?
Yep.
Okay.
Alright? Oh, you mean...
Right, that's the x.
No. No,
That
this is...
originally was a negative 5x, so wouldn't it change it to positive 1/5?
Yes, because I covered that up. Sure would. That is a point.
Hey, you need to tell me
Okay.
when you say stuff.
That is a point. I covered it up and didn't see it. Alright, so that is a -5x equals -1. So that means this is a positive 1/5. Now, it's going to be kind of aggravating to graph 1/5. That's 0.2. That's going to be just a little bit past 0. But we're going to do the best we can with it. Right in there. And then you can draw your line. Okay? Alright, y'all do number 2. And again, if I were you, I would get it in I would get the x and the y on the same side. And that's going to help you find the x and y intercept. So in this problem, like before, it's a good idea to go ahead and get the 6/5 x on the other side. Alright, so we're just going to add that to both sides. That will give us y plus 6/5 x equals 2. Now, for my y-intercept, I'm going to cover up the x. That leaves y equals 2. That's super easy. Then for my my x-intercept, I'm going to do 6/5 x equals 2. Now, there's a couple ways you can approach this. You can multiply 5 to both sides and then divide by 6. Or you can just multiply both sides by the reciprocal of this. The reciprocal of 6/5 is 5/6, right? So I cancel those out. That leaves x equal to 10/6, which reduces to 5/3. Now, 5/3 is 1 2/3. That's almost 2. Almost 2. So, when I graph these things, y equals 2 is right here on the y-axis. X equals 5/3 is almost to 2 on the x-axis. And then you graph your line. Okay? Very simple. Alright, I'm going to let you try the next problems.
Oh, I had it right.
So, in number 4, we want to find the y-intercept. We want to find the x-intercept. Okay, this is very simple, guys. To find the y-intercept, just cover up the x, but don't cover up the negative. Negative y equals 8, so then you just change your signs. Y equals -8. And then for the x-intercept, cover up the y, which leaves 4x equals 8 and x equals 2. Are these things not easy or what?
They're hard. They're super hard.
So y is -8, so we're going to go down 3, 6, 8, 2, 4, 6, 8. Alright, and then x is 2, so I go to the right 2 on the x-axis. Guys, the things that I see mistakes, where I see mistakes are just simply knowing what the x and y intercepts are, knowing what the x and y axes are, and then knowing to put the x-intercept on the x-axis and the y-intercept on the y-axis. All right, we're going to do one more of these. We're going to go straight to it. Let's look at number 6. All right, on number 6, x and y are already on the same side. So, when it comes to finding the x and y-intercept, we're already a step ahead. All right, so we should have, for the y-intercept, negative 1/3 y equals negative 2. Alright, so when we solve that, to solve this quickly, we can just multiply both sides by negative 3 over 1, which is the reciprocal of negative 1/3, so y equals a positive 6. Does everyone see why this is? Negative 2 times negative 3 is positive 6. Alright, for the x-intercept, cover up your y. 3/4 x equals negative 2. So, to solve this, multiply both sides by the reciprocal of 3/4, which would be 4/3. Those cancel. X equals negative 8 over 3, which comes out to be 2 and 2/3, I believe.
Yeah.
Goes in there 2 times 6.
Negative 2/3.
Yep. Negative 2 and 2/3. Alright, so that means that's almost negative 3. So for the y, we're going to go up 6. 2, 4, 6. For the x, we're going to go to the left almost 3. Not perfectly, not all the way to 3, but almost 3. And there it is. Questions about these? Pretty simple, right? Alright.